All right, I think we'll go ahead and get going. I'm Jeff Talbert, the professor and division chief for Biomedical Informatics in the Department of Internal Medicine in the UK College of Medicine. I also serve as a director of the Institute for Biomedical Informatics, which is a campus-wide center, reports to the VPR, and our mission is kind of much broader than just medicine. We're really here to serve campus on cutting edge and develop cutting edge informatics solutions. And we're looking forward to working with anybody that wants to work with us. Benefits include access to our resources, staff, and infrastructure to support your projects and your proposals. Today we highlight some of those resources developed by the Center for Applied AI. The center was created by the IBI and from our work with the College of Medicine's Research Alliance Award. So we had an award called the AI in Medicine Alliance, AIM. And when AIM was active, we awarded 7 pilot awards. We supported several grant applications, including several that were actually successful, including one of my own. And we then we took what was left over from AIM and we said, we don't want this to go away. We liked what we were able to accomplish and the people that we pulled together. So I sat down with Cody, who's one of my associate directors at IBI, and we said, let's come up with a new center. And we came up with the Center for Applied AI. And so Cody is the leader of the Center for Applied AI. He's an associate director at IBI. And Cody has been a great visionary on how to get our AI activities going here at IBI. He's got the passion, the experience, and he's here to make a difference at UK, which I really appreciate and like a lot. We're fortunate here to have him here to lead the center and really to help UK catch up in our activities in AI. I'm excited for you to learn about some of the tools that the team has developed. We want to provide the latest AI technology to UK researchers, and we want to do it in a safe and secure environment. So much of the conversation around AI today is how do we limit it and the risks that it involves. But we recognize those risks, but we want to encourage and help researchers engage with AI and help them do it the right way. Thank you again for coming today. We appreciate your engagement. Now I turn it over to Cody to tell you more about the events that's going to happen today.
I didn't know that Jeff was going to say nice things. Would have brought him something. I was actually going to talk about how little I've done to support this particular event. We've probably done 6 or 7 over the last couple of years. And in the past, I've done a lot of work with others, trying to create content, getting people to come, to show up, and getting people to care about these things. I did not contribute a single slide to this event, and I think it's a testament to the folks that pull this together. You know, early career people that are working in a really rapidly evolving area. And I don't think that the folks that are working in this space, that maybe this is their first job, can't yet appreciate how fast things are moving, how fast things are changing, and having to learn how to learn is something that you're going to have to continue up in this to do in this particular space. So I really appreciate. I know Caroline's put a lot of this together. Mitchell, Aaron, Noah, Sam. The core team that you're going to hear from today has put all of this together. The only other thing I think I would say is that this is the surface, and I've heard several people repeat this, and I believe it, is that if AI advancement stopped today, like if the core technology of large language models didn't advance one bit, it would take us 5 to 10 years to actually implement these things in like healthcare settings. I think to exhaust the implementation. There's so much low-hanging fruit in medicine, just in automation. Forget about taking and having virtual agents doing work on your behalf. And I think what you'll see today is that we can do these things safely and with an audit trail, and we don't have to leave the decision making up to the models. You know, so this is more of a in the loop. We have things that are highly structured, but then where it's reasonable to have a language model that's informed, make some decisions that are verifiable, then that's a lot of savings. So show of hands, is there anybody here that's not from UK? I know there's at least a couple. Okay, so there's a good part of the room that's not from UK. And how many people are in medicine? There's quite a few in medicine. Okay. When we would give these talks and develop technology over the last 20 years, and we would come up with something really cool and say, look at this neat, shiny thing that we have. Will you please use it? It would be really great. And maybe you get a report out of it. It was really hard to get some idea to where people would actually use it, especially in highly regulated areas like medicine. ChatGPT changed this to where we now had people coming to us saying, my workload is so heavy that I have to find something to work. I found this transcription service. I found this model that will summarize text and notes. Like, I know I'm not supposed to be using it, but I have to. So I think what you're seeing are things that we're now demonstrating from an applied sense, that they are useful, and they're useful in these areas. Doesn't mean that we can't use them elsewhere, but if technology is useful, people will use it. And I think I'll close in saying that this is just the beginning, and I hope you're excited about the upcoming presentations and that you can think about how that would be applied in your own area. And we encourage everybody to reach out to us with potential ideas and projects, and we'll try to figure out how to fund and support these things. So, thanks.
Thank you, Cody, and welcome everyone. My name is Caroline Leach. I'm a data management specialist here at the Center for Applied AI, and I really appreciate everyone here in person and online that joined us today. I just wanted to give a brief overview of our agenda. So this first half of our workshop today will be giving some background on LLMs, talking about some of our current efforts and the tools that we've developed. And then after we break for lunch and conversations, we are going to get into some more technical demos and discussions on methods. But I want to emphasize that, especially in this first half, we want everyone to feel like they can raise their hand, ask questions, stop us, let us know if you have any questions or comments as we begin. The kind of objectives of our first half of our presentation here are understanding what an LLM is, why they're powerful, and how they can be used. There was a definition sheet at the sign-in table, and I know it's been shared in the meeting chat as well. So if you're not quite as familiar with AI or large language models, you can always refer to that for some quick references, but we'll try to keep it high level and describe everything as well. And then we are the Center for Applied AI, so we're going to talk about AI applications and how we're using it in our projects that we work on every day and in research. And then we'll introduce LLM Factory, which is a system that we've developed. You'll hear more about that later. And yeah, with that, I'm going to hand it over to Mitchell.
Morning, everyone. My name is Mitchell Closey, and I'm a software developer here at CAI, and I do a lot of work with LLMs and stuff, so I'm going to go over kind of just what an LLM is and how you can use it in some of your work. So first off, things like ChatGPT, Copilot, Claude, probably you've all used LLMs in the past. Has anyone not used an LLM? Okay, that's what I kind of expected. So basically just you give it a query and it gives you a response based on natural language, and it is really good at processing that language. So it opens a lot of doors to new technologies and stuff because we can apply these LLMs in ways that we never could before. So what this means is that you can talk to an LLM and it knows a lot of stuff. So there's already that embedded knowledge in it. And also it gives you the ability to introduce natural language processing into applications that you would never have been able to before include those natural language processing stuff. So with all of these current existing LLMs, it's kind of confusing sometimes of what the differences are. So just want to highlight a couple of the big differences between each model. One of those qualities of model is the size of it. So for instance, ChatGPT, you might know about GPT 4.0 and GPT 3.5. Those are different size models. So 4.0 is a bigger model and it has more costs associated with producing outputs there. The quality is better and the speed is lower. And then same thing kind of with increased context size. So basically what context is if, for instance, you want to give a PDF to an LLM and have it look at the PDF, then some models have smaller context sizes, so they're able to look at maybe one page at a time. Whereas other models might be able to look at 10 pages of that PDF because they have a larger context size. And then with this increased context size, you get higher quality because you're able to tell the LLM more information about your specific use case. So that obviously is going to make its output more related to your specific thing. But then that also comes with a higher cost because you're putting more tokens in, more tokens coming out, and that it just costs more to have an output. And also the speed goes down because it's processing more. So while there are trade-offs there, generally if you want a better output, you would like to use a better model, but sometimes it's not really feasible to support that with your current infrastructure and stuff like that. So you want to go with a smaller model or quantize it down, stuff like that. So one big limitation of LLMs is that they don't have any information that they weren't trained on. So like if, say that ChatGPT was like the last version of it was trained on, say in like 2023. Things that happen in 2024, obviously it doesn't know about that. So it can't give you current information because it doesn't know it, obviously. But it also, if there are like particular domains that the people that train ChatGPT or any of the other language models didn't include in the training data, then obviously the model doesn't know that as well. So that brings up an issue of how do we introduce new information that the models just don't have access to? How do we let that natural language processing that the LLMs perform, how do we apply that to data that isn't in the models? And a couple methods that we're going to go over today are adapters, RAG, and tool calling. And we'll get deeper into all of those. So first with adapters. Traditionally, if you wanted to retrain a model, or if you wanted to add more information to a model, you would have to retrain the entire thing. And this is not really feasible at all with language models because of how big they are, and it's just not a possibility. But one thing that we can do is we can make adapters, which are smaller little pieces of the model basically that you can add on to the end. And essentially that little small model will get merged with the larger model and allow you to add on that context of here's this small bit of information that I want you to know and apply that to the entire knowledge of the LLM. And what that lets you do is it lets you, again, go into the specialized information. So if you have something in a particular medical domain, for instance, that the model just doesn't know much about, you can train an adapter that will extend the model's knowledge and allow you to apply that there. And it also lets you adjust the way that the model talks, essentially. So for an example of that, one project that we had where we had to use an adapter was we were trying to set up a system where a social worker could talk to an LLM as if it was a child or a teenager that was dealing with some tough issues like suicidal thoughts. And when we talk to the base model, the model without an adapter, and you instruct it to pretend like it's a child that's having suicidal thoughts, the model doesn't really want to do that because there are certain guardrails there to keep it from talking about really sensitive topics like that. So the model, you would ask it, can you tell me why you're having these thoughts? And it would spit out something like, I can't discuss this sensitive topic, let's talk about something else. So that really, obviously those guardrails are put in place for a reason, but that doesn't really help us with our research because we need it to not have those guardrails. So one adapter that we were able to apply to this model was called the uncensored adapter, and that just removes that guardrail. So once we apply that, it adjusts how the model talks to us, and instead of hitting that guardrail where it's saying, I can't talk about this topic, let's talk about something else, it starts actually responding as if it is a child in this situation and they're talking to a social worker. So that has a lot of different applications for how we can do that. But this doesn't solve the problem of sorry, I forgot to go over this. In this example here, for instance, if I ask the model what the weather is like today in Lexington, it's going to give me this response. And this response is a weather report, but it's not the weather report of today in Lexington. It's just a weather report with some numbers thrown in there. And that's because the model doesn't really know what a weather report or what the weather of Lexington today is. It doesn't know what even the weather report means. It just knows what a weather report looks like. So since I ask it for a weather report, it spits out a weather report. But none of that information is correct. And it also presents it to me as if it is correct. So that's called hallucination, where the model will present information as if it's correct, but it doesn't actually know that information is correct because it's not. So instead of presenting the accurate model or the accurate information about the weather, it gave me this. So then that brings me back to this. If I were to train an adapter on the weather report, then that may have the information for today, but then I'd have to go back and I would have to train another adapter for the weather tomorrow. And that is not really feasible. We don't want to do that. So another way that we can do that to kind of do that kind of stuff is called RAG, and that stands for Retrieval Augmented Generation. So what that does is it allows you to store data outside of an LLM, so you don't have to adjust the LLM at all. You don't have to merge weights or anything like that. You can store it in a standing database, and then that data you can add to that data, you can move from that data, and all of that information is accessible to you at any time in the model. And it also lets you query that database with structured language, or with normal language, rather than with like a database query. So you can ask it just a question about the data, and instead of it having to like take your question, convert it into an SQL query, for instance, and then convert that into getting the results from the database and then convert that back into natural language, you can just ask it the natural language, and we're able to pull that data down and give that back to you as a natural language answer. So, for example, basically, if I have this database here in orange, where it's just a bunch of unstructured data, just a group of body parts, and I want to search that for the circulatory system. If I look at that data, the circulatory system is not in this database, so I'm not going to get any results. And that is not really acceptable because we have like heart, we have arteries, we have, I think blood is in there and stuff. So what we can do with RAG though, is we can convert that into a vector database through a process called vectorization. And what that does is each of these entries in the database is going to get converted into a vector, which is just a set of numbers. And you can think about it kind of like on a coordinate plane. So for instance, like muscles up there. Muscles would be at, let's say, like -1, -1. And that would, through the vectorization process, it looked at the word muscles and determined contextually the meaning of this word is -1, -1. You don't really need to know how that works, but just understand that it can convert it into those vectors. And then from that, we're able to search on that. So if we want to look for a circulatory system in this, we would vectorize it in the same way and get the coordinates in this vector space. And then from there, we can apply that to, we can find that circulatory system is that point right up there. And from that, we're able to search in a particular space and find the most related elements to it. So now when we look for circulatory system, we find arteries, we find heart, blood, veins, and capillaries, whereas before we didn't find anything because the words circulatory and system are not in the database. But we're able to find the semantic meaning of circulatory system and find what it is related to and extract each of those different entities. And from there, or for instance, if we want to do respiratory system as well, we could do the same thing, put that in there, respiratory system might land where it is there, and we might hit lungs, nose, larynx, and oxygen. So to apply that to an LLM, what we do is we ask the model to tell me about the circulatory system. And then we also ask the RAG database, give me things related to the circulatory system. So then those documents in there would pull out blood, heart, arteries, capillaries, veins, and put that into the context of the LLM. So then the LLM knows I need to talk about these things. I need to talk about these things while I'm going over my answer. So it merges the knowledge that you provided in your custom database and the knowledge that the model of the LLM has and the processing power of being able to handle language. So we're able to combine like a standing structured database and put that data into an LLM without having to like recode the entire LLM. Yeah.
So for the data in the database, so people have some context for that. Where does that come from? What is your source? What kind of source information can you use?
Yeah, so basically any text or anything. So like with these examples, this is all really small just for a demonstration, but instead of just blood or heart, you would have like a piece of a document that contains information about blood and heart. So you'd be able to like have specific characteristics about that. So like if you have a block of text that explains what the heart does, maybe goes into some of the diseases in the heart, then you'd be able to search that database to find some related examples to, like, circulatory system involves heart, so now I pull out information about, here are some of the heart diseases and stuff like that. Does that make sense to everybody? All right. So another method that we have is called tool calling. And tool calling is basically you're able to define specific code, and it allows you to merge in together the language processing power of LLMs with the code running of just normal code languages. So in this example, we have a weather lookup. So going back to our weather question earlier, if I ask it what the weather is today, I'm going to go and look at the toolkit that I've defined for the LLM, and I can have different code that I describe in different ways, and it will look through browser search, weather lookup, plot maker, Epic API call, or calculator, and think which one of these is going to be useful to answering the question. And obviously weather lookup is the best one. So it chooses weather lookup, and it's able to look at that query and find, I need to go to weather lookup. What does weather lookup need? So the weather lookup code is defined within the LLM to need a location and a date. So then it looks back at the query and it says, what is the location? And it sees Lexington. So it pulls out Lexington, puts that into the field for what it should be, or where it should be looking. And then it looks at today as the date. And it's able to use code, normal Python script or C++, whatever you use. It's able to convert today and get today's date. And then it is able to go out and hit an API, a request from any other service that it wants to know the weather in Lexington on September 18, 2024. So we're able to connect the language processing to go out to an external database through code, which allows you to more strictly define how the LLM should process the data that comes in. And then if we look at this, it gives us the weather report of Lexington today, and that is actually accurate. So compared to the previous number, or the previous version where it just like threw some numbers in there and assumed that that's what the weather report looked like, we went out and we looked at like weather.com or wherever, and we said, what is the weather in Lexington like today? And we got, oh, the high is 83, there might be small showers in the morning. So it is able to tell the LLM the information that it needs to answer the question properly, and do that in a way that is actually structured and prevents hallucinations by it telling you that something's right when it's just not right. So when do you use each of these different things? For adapters, you want to use that if you want to change how the model is talking, or if you want to add knowledge to the model that is not going to change. So things like medical knowledge that is like probably not going to change for the next few years, that is something that you could encode in an adapter, and it would stay static, it would be good, you wouldn't have to retrain the adapter for a while. Or something like the uncensored version where it removes those guardrails, that's another version where you'd want to use an adapter. For RAG, that would be something if you have knowledge outside of the data, outside the LLM that you want to be able to access, then you'd want to use RAG. And if you want to be able to adjust that knowledge as well, then RAG is a good option. And tool calling is kind of the same. Tool calling a lot of times will use RAG. Tool calling and RAG are not separate entities. You can use them together. But generally what tool calling is it allows you to connect the language model to code that you want to execute. So it gives you that capability to mesh those together. So what are some barriers to using these models? LLMs, like we said earlier, generally are not trained by anyone except very, very large organizations that have the resources to train them. So OpenAI, Meta, Google, they train their own models, and UK is probably not going to train a model in the next many years because of just how costly it is to get the infrastructure and get the power to run that infrastructure for long enough to be able to train a model. So that is one barrier to being able to use your own model, but how are they accessible? You can either use something like how OpenAI has the OpenAI API for ChatGPT, GPT-4, and you can go through one of those organizations. Well, that comes with the downside that the cost of using those services is pretty high, and you have to put your data through an external company, which is sometimes not an option, especially in like HIPAA protected areas. You don't want to be putting your sensitive medical data through OpenAI because you don't want them to have access to that, store it somewhere that it shouldn't be stored. And your other option is locally hosting your model. So some models like Llama, which Meta makes, are open source. You can pull those down, you can use them locally. But in order to use them at a sustainable pace and at a way that is going to be useful for a project and doesn't take a long time to execute a query, you have to have a lot of resources. And the infrastructure to set that up and to maintain it for a long period of time it's not really worthwhile for one single project unless the project is pretty big. But generally a better way to go about it is having like one secure centralized way of accessing these models. And if we could do it through OpenAI and have everything be secured there, then that would be great. If everything was affordable and sustainable there, that would be great. But that's not really the case, unfortunately. So I'm gonna hand it back over to Caroline to go over our solution.
Yeah, so exactly what Mitchell just said. There are definitely some downsides, some barriers to using things like ChatGPT or some of the other major well-known LLMs out there. So that's why we have LLM Factory. It's a self-service tool that the amazing technical team here has developed and is, currently up and running. It solves those problems, so it's customizable, it offers flexibility, meets security and privacy concern things. It's compatible with OpenAPI, which is the industry standard, and it's pretty accessible. So we just heard about how powerful LLMs are. They're a great resource, and they're definitely a buzzword right now, and so it makes sense that you would want to use them in your research, but they're definitely, whether it's the resources or the cost or the security concerns associated with them, some things that limit their use. So LLM Factory addresses all of those challenges, and it's our hope that offering something like this or collaborating with us and using a tool like this increases access to kind of the latest and greatest models and AI advancements so that they can be used in your research or translational science. So talking about customization and flexibility for a minute, we learned about adapters, RAG, and tool calling when Mitchell just spoke. And so being able to fine-tune your own model and have it specific, tailored to your needs is really appealing. And so you can do that with LLM Factory. You can create a model that is an expert in your domain, and it's also secure, so you can use data that is specific to your project. So whether it's personal information or protected information, we know that privacy is essential in all of this and a big concern when it comes to AI. So everything LLM Factory is hosted here locally on campus. We developed it here on campus. We are the people who run it. And so all of your interactions, whether it's through the web interface of LLM Factory or like backend coding via the LLM Factory API, it's all secure, private, controlled by you. Any data that you upload to train an adapter, anything like that, is any of it stored locally, and it's all encrypted. I also want to just mention, I know there are a lot of people in here today from the medical community, so we do have the ability to create HIPAA compliant instances of LLM Factory, and we're able to do that kind of on a individual needs-based basis. OpenAI, they're the ones who created ChatGPT, GPT-4o, and they were kind of the first ones on the scene to do it really big and to share it with the world, and that has made them the industry standard, which means that a lot of the advancements and a lot of the research, whether it's here or at any other institution, it is compatible with LLM Factory. LLM Factory's API can be used with OpenAI APIs, and so being able to offer that further increases the amount of tools and technology that you can integrate with the system. All of this serves to kind of further ensure access to libraries and tools so that you can, again, leverage the most cutting edge, up-to-date models and AI developments. I'll speak about accessing it here for a moment. So we have on campus some really impressive and very cool kind of hardware that supports LLM Factory, and doing it locally and through what's called low rank adaptation, or LoRa, we're able to kind of do fine tuning at scale for less cost. And basically that's because of the technology and the hardware behind it. It cuts down on memory storage and computing resources so that you can access LLM Factory, and it makes it a bit more equitable. Maybe you're thinking, how do I use this tool and work with us? In a couple slides here, I'm going to put up a QR code where you can tell us about some of your projects or ideas that you have for LLM Factory. But speaking again about the high performance computing cluster, NVIDIA, another powerful organization out there in the world of AI. We have a DGX on campus, actually just in the data center, and so using state-of-the-art technology like that allows us, again, to offer LLM Factory and work with it at scale. So I also want to mention that the base model, kind of the foundation of LLM Factory, is Meta's Llama 3 model. We heard Mitchell talk about kind of layering things on top of that. So that's what the low-rank adaptation is. It's pretty costly and time-intensive and takes up a lot of resources to build your own LLM outright or to do kind of traditional fine-tuning. But with these advancements, we're able to load up models only at the time of query when they're relevant. We're able to kind of host a bunch of adapters at once. And all of that, again, further serves to ensure that we can do this effectively and minimize the cost associated with it. I'll also mention soon, we're always making advancements and updates to the system. We're going to be upgrading to the recently released Llama 3.1 model. You might be wondering what those numbers next to it mean, 8B and 70B. That's billions of parameters. So having even more parameters with that new upgraded model will further ensure that you're using the latest and greatest technology there. In addition to these natural language abilities that are built into LLM Factory, there's also transcription and text-to-speech models that we host and have available to users. So maybe you've used it on your own in your own work, but OpenAI has something called Whisper. That's something we are able to interact with and run locally on its own. Whisper is great at transcribing shorter audio files, but again, our amazing technical team has made it even better, and they are now outputting noisier, longer files, amazing transcripts that have accurate speaker labeling on them. So that's a really cool recent advancement that we're able to share today as well. This is just a screenshot of the LLM Factory interface. So if you use it, this is kind of what it looks like when you sign in. And to say how important it is, we use it every day. I'm a part of many projects that this tool is used for in every single one of them. So being able to use it yourselves, collaborate with us. It's definitely our go-to right now, again, because of those security, control, flexibility, and reduced cost factors that it allows us to offer. So with LLM Factory and with the Center for Applied AI, we're able to turn things around pretty quickly. You'll hear here in a little bit about some of the tools and things that we've developed through existing and past collaborations, and having those tools, while they were developed for specific purposes, they can be used in general settings too, and they can kind of be selected and combined in new ways to meet your own specific project needs. So you're going to hear more about those here in a little bit, but this so far is a little intro to LLM Factory. If you are interested in collaboration, or if you're interested in using LLM Factory independently on your own, we have this collaboration request form. So this takes you to a survey that you can submit. Tell us a little bit about your project, your goals with AI, and our technical team here is really great to help you figure out the best way to use it, point you in the right direction, or do like a formal collaboration and work with you on your projects and efforts to implement AI. Are there any questions? Yeah.
First up, that Demas Group did the design on the interface, so I think a lot of these aren't just kind of engineering people in a bubble trying to figure out what works for different groups, how things may work for one team but don't work for the others, so we have flexibility on interfacing and things like that. The only other thing I'd mention, because we've talked about how hard it is to train models and how easy it is for us to train models, they're kind of, when we say model, that's a bit overloaded. If someone says they're training a model that you're talking to, unless you happen to have a friend that works at Meta or NVIDIA, they're talking about fine-tuning of the model, not training a new foundational model. That's where you see people buying 100,000 servers and affecting the power grid. The initial training of that brain, of that large language model, is incredibly costly. You know, you're talking about not just tens of millions now, getting into hundreds of millions of dollars to train. When that becomes open source, that's an incredible amount of investment that then now we can adapt and use. So we train additional material on top of it. We still get to use and take advantage of that brain. To my knowledge, that's not happened really in the same way across technology ever that I would know of, that there's these huge models that are incredibly useful that you can just download for free in there's some code. But yeah, so this is what's driving a lot of this.
Absolutely, yes, thank you. Any other questions? Yeah.
You mentioned that LLM Factory is specifically configured for compliance. Is that something that you available today, or you're working on?
Yes, so that's something we can do. If you are interested in that, absolutely. I think there's a box on that form to tick, but because we store everything and control everything locally on campus, I know that the data center already has HIPAA compliant inference servers, storage servers, things like that, and both in transmission data being moved from place to place, and when it is at rest, it is encrypted, and so that further serves the HIPAA compliance guidelines there. But that's absolutely something that we have capability to do. So if you're interested in that, or if anyone is interested in that, definitely let us know.
So this is fantastic. Thank you for doing this, and this is also important. I'm curious about your timeline. Maybe you're going to get to it in the next slides. But you mentioned 3.1 7EB, Llama 3.1 7EB. You're going to get that going. Have you looked at Gemma as well? And then sort of in relation to that, I've been going down the path in my own projects to get the ability to use Llama 3.1 and Gemma sort of locally on my own Because I have, or, you know what I'm talking about.
Yes.
No, I don't ask anybody for permission. Because we're regulated other ways. If we're gonna use it for a specific project in the hospital, then people are gonna look at it. You may have to fill out a IVF form where it's 500 pages, and then the same thing with the IRB approval. So if we were trying to use OpenAI for certain things, and we're trying to establish a contract for everybody, then I think that would be a big hurdle. Otherwise, for this stuff, we treat it like we do any other application. We have no licensing agreement with anybody, so it's treated like an app.
I see. So did you do the risk assessment or whatever, you know?
Well, it's in this compliant data center where this is in, so it's
Okay.
it's out the union. The stuff that we have that's available programmatically externally, that's obviously not. It says right on it, don't use this for anything sensitive. But yes, the things that we have in the NIST compliant data centers, we consider them NIST compliant. So they've gone through lots of review.
Right. Okay. Sounds great. I'm excited about it.
Yeah, absolutely. And I'll also just mention that we have developed this tool. It has come a long way. It will continue to evolve and grow. But at this point, it's kind of available like as think of it almost as like a little bit of like beta testing level. So we use it in our own projects, each that I'm involved in, several of them, and you'll hear more about those after our break. But that's kind of how I would say to think about it is absolutely share your ideas. We can talk about these things on an individual kind of specific level, but maybe a good way to think about it is kind of like that, building out that proof of concept. And then once we know, okay, this is gonna work, we're gonna spend some time and go down this path, we'll get all those boxes checked that need to be. Was there a question online?
Yes, there was a question. Will LLM Factory support additional models such as obliterated models, since it's mentioned that there are safeguards on most models when talking about difficult subjects like suicide or drug abuse?
Yes, so that is a good question. Talking about hosting different models. Currently, the model that is in LLM Factory as the base model or like the foundational model is Llama 3B, but I do know that we have built out already what kind of I'm referred to as public adapters. So if you have an LLM Factory account and you're accessing the system, there's a handful of adapters already available and ready for use, and one of those is the obliterated uncensored model. There are a couple of code generation adapters that are available. I believe there's another uncensored model called Lexi, but those are available not as the full models, but as adapters that you can kind of turn the volume up on.
Yeah, that's a good point. And you're talking about before, the reason we don't go between different versions is that the efficiencies that we're getting with the adapters has to be within the same model architecture. So if you find a model out there that has been trained on, some Gemini or something, and say, I can't use that. I mean, if we had a larger infrastructure, then we could have 3 or 4 lanes of different things we're inferencing. But if you can find something that's been trained on the same base model that we have, there are methods to go through and extract adapters, so we don't have to train them. We can just extract those adapters, and the output, depending on at the level that you extracted at the rank, which they'll go through later this afternoon, it will take over it'll be 99% the same as the full model, which they probably merged the adapter to begin with, so you can reverse that.
Yes.
I don't remember. Does Meta 3, the model that uses the does it process images like multimodal? Like, is there any plan to do
It is not a multimodal model, no.
Is there any plan in the future?
Yes, absolutely there is. Plans to integrate that into there.
Yeah, part of that is the inferencing costs are fairly large. The first model that we posted at UK was actually a multimodal model, but then you're stuck with that particular model. So a couple of things have to happen. One, we need additional inference services to kind of run this anyway. 2, what's happening is that if we have a base model with then language on top of it, like there are language models, then we can take advantage of that same infrastructure, and like we're turning on adapters, you turn on vision adapters, you turn off vision adapters. That's being developed right now as far as the inference servers go. The other piece adapter that's concatenating the information and model releases, then people will very quickly be able to support both text and image models. So we can do it today, we can train them today, we just don't have good ways of making them available to other people.
Is the microphone still up there? They cannot hear the audio.
Any other questions?
Can we use our own data set in the LLM Factory? Like we're talking about the RAC, am I right? So in the RAC we can upload our own data, but I'm worried about the data security. Like we can have a confidential data, but how secure is it? Because it's going to post to the local server, am I right? So yeah.
Yes, so the question was about using your own data to train on LLM Factory and the security associated with that. So being able to have everything local on campus, as Cody was saying, we have the data center where it's currently operating out of is NIST compliant.
Yeah, so I would not say that the current self-service tools are secure at all, like not at all.
Yeah.
Okay? So when we do anything with medicine, with medical reports or anything, we're using the same hardware, but we're not taking the same path.
So I see that it's for the biomedical informatics, but I have some kind of data which really talks about the, suppose I have a data set from the high temperature. So does the model performs well with the other kinds of data sets because it's built for the institute for biomedical informatics?
Yeah, so keep in mind, we're using off-the-shelf models, generalized foundational models. You know, some of our stuff may be in agriculture, some of it's medicine, some of it's maybe in mental health. So you're adding layers on top of that. If you came to me today and we do this in, like with substance abuse or something that had people's names all over it that you wanted to use in a controlled setting, we would still take the same underlying infrastructure, use the same tools, same approaches. It just wouldn't go through that public automated self-service path. Now, I do think that we're in a position to build out that automation. We take it in copy and paste what we have that's publicly available, and do that in a protected way. But that also requires going through a lot of the efforts that were previously mentioned about how's it secure, who can use it, what's the access control. So we're positioned to do that, but if you want to do it now, it would be more of a manual process.
So is base model able to generate the images because I have gone to the LLM's platform before coming here, and it's pretty much insightful and cool. But is it able to generate images, or we have to create the adapter for generating the vision transformer or vision features?
So we want to talk to Break the Mood, and he's done a lot of generative AIs, and we do not have anything that generates images publicly available because nobody's asked for it. But we do have a lot of work in that area where it can be done. We're also working on foundational models for pathology and radiology as well, using UK and other data. So these are, once again, if there's a general tool or general need to do that, then we can prop it up like we did with embeddings and speech text, those sort of things. But yeah, maybe that's the next thing we need to do.
Thank you very much. That's great.
We have another question online. What is the greatest limitation faced when developing the LLM Factory software, and what ways are we looking to overcome said limitations?
Across the country, there's almost no place to do inferencing, and that's where I think we're going to be successful with some infrastructure grants, especially if we have other institutions that are working with us and we can distribute that. So there's lots of places to go and train, lots of services to go train. You can go get things on national labs and cloud providers. But then what happens when you actually want to use it? You've got a model that works in offline testing and it seems great, and then you have to prop it up and have other people use it. That's a problem that we're trying to solve by using some standard back-end models that then we adapt and then give people access to those front ends that then looks like it's their personal model, but it's not. So that is probably the biggest challenge, is that if I have to support one model, it costs me the same as supporting, in some cases, 1,000 because of the way that the models are typically deployed. And we're addressing that by using adapters, by standardizing on the base models, and then trying to consolidate some of the computational capacity, and then but still isolated between different groups. We just submitted a paper on this yesterday that goes into detail, but we still do have papers giving a high-level view of how this works. You want to look into it in detail.
All right, thank you everybody. We're gonna take a quick break for about 10 minutes. So we'll join back here after that for another presentation and a quick testimonial before we have lunch in about half an hour. But feel free, get up, stretch your legs. There's a restroom across the hall. And yeah, we'll reconvene in just a couple minutes at the top of the hour.
All right, welcome back, everybody. I'm going to go ahead and get started here. So I am Aaron Mullen. I work here at the CAAI as a software developer, data scientist, and I'm going to talk briefly here now about some of the specific examples of ways that you can use these tools to specifically interface with different kinds of external databases. So maybe you can see applications for some of this in your own research, and I'm just here to help give some examples of how this can be done. So the first example I'm going to talk about is FIHR. Now FIHR, if you are not familiar with it, is the Fast Healthcare Interoperability Resources. Essentially what it is a schema for storing different kinds of healthcare data. So if you imagine a big graph full of a bunch of different nodes, and each node might be a patient or an encounter, a treatment, observation, anything like that, all of those would be treated as kind of separate nodes that are all interconnected in different relationships. And so if we have a database that looks like that, we can actually use it as an external data source for the RAG that we talked about just a bit ago, to be able to allow the LLM to actually use the data that's stored in that database and use it to kind of answer any questions. So this is a very, very small snapshot of what like a graph database would look like if you haven't worked with them before. Like I mentioned, there's different kinds of nodes, patients and encounters and procedures here, and they're all interconnected in different ways. Each of those nodes also has a bunch of different attributes that kind of help describe some of the data about that attribute. So if you have a patient, it might have data about their birthday and their sex and where they're from and all of that. And so with this, this is a very complicated schema. This is only a small snapshot. The actual database has thousands of different types of attributes, nodes, relationships. So it can be very difficult to kind of understand the structure of the database. So if we had a question, like we wanted to know how many people in this database are under the age of 30 at the end of 2021, one way we could do it is open up the database, find all the patients, and figure out all their ages. Obviously, we wouldn't do that. There are different query languages that can be used to interface with different kinds of graph databases. So for example, Cypher, if you've used that, is a language used to kind of ask queries of this kind of data. But that can also not necessarily be easy to learn or use. And so that's where we hope the LLM could come in. And it turns out that they are actually pretty good at doing this. So what we can do is ask it a question. This is just an example of some output that you might see. It says the generated cipher, and it creates this kind of long query. And it's essentially just finding patients where the amount of time between the end of 2021 and their birthday is less than 30 years. And it finds an answer. And so it tells us 44 patients are under the age of 30. And so these kinds of questions can be very useful because, as you can see, that query is a bit complicated. It's not very fun to write or execute and debug. So the idea here is we can have the LLM do that for us. By allowing it to write its own queries, it can run those on the database itself and use the results from it as context. So any kind of human language questions we can ask of this kind of thing. Another example is using APIs. We mentioned that a little bit before, but in this example, we're using clinicaltrials.gov, which contains a bunch of different data about different kinds of clinical trials and some data about them. So if we needed to know some studies related to lung cancer in Kentucky that are currently recruiting, again, we could write our own query, define all those query parameters, and then send it off to the website to get our response, and then we can try to interpret what that response means. But it's much easier to let an LLM do it instead. So in this example, we ask it the question, it formulates its own query with all the parameters, and then returns a response that looks like this, where we can see for each thing, we have a title, location, descriptions for all of them, and we can specify what kind of data we want if we are looking for any kind of specific information here. So these are just some of the general ways that this kind of tool can be used to interface with other kinds of external databases. Are there any questions about this topic? All right, well then I will hand it over. Next we're going to talk about some other specific projects and use cases that we've done with this kind of work here. So Mitchell.
Yeah, so we're going to go over some of the projects that we've actually gone through and been working on recently since we've developed LLM Factory and how we've used LLM Factory as a backend. So the ones that we're going to go over are AgriGuides, that's with the College of Agriculture, OptimalCT, which is with UK Healthcare, and then Speakeasy, which is with the Nunn Center for Oral History. So we're going to just kind of discuss what those are and how we applied LLM Factory to them. So the first AgriGuide, what that is it's a collaboration with the College of Agriculture. They wanted a way to be able to access their resources and have people be able to go to an LLM and ask specific questions about agriculture and it know the answer based on UK College of Agriculture data, and kind of be able to help the extension agents that they have with answering questions and helping out the local communities that may want to use this. So how we did this was with some of the RAG techniques that we talked about earlier. So we create a tool that allows you to search the College of Agriculture websites, and how we do that is each of those websites needs to be searched and indexed. So we created a vector database that stores what each of those websites are about, and then we have that stored in the vector database. And then when you want to ask a question, you give it to the model. Like we talked about earlier, it does RAG search on the vector database, and it looks for which websites are applicable to that question. It then can load the contents of that website and search that content for the answer to the question, and then provide that answer back to the LLM. And that LLM can then answer it with that context and provide an answer. So in this example, what pests attack pepper plants in Kentucky? This answer, where it talks about the different pests, is pulled directly from a College of Agriculture website. So it helps us with, we're able to come to different groups, and they give us a set of websites or a set of just documents or information, and we're able to really easily now build out these vector databases that we can then search information on. So we're able to connect with different groups that want to be able to create an LLM that's specific to them, and really easily set up these systems that are able to host this data and then query that and give it to the LLM. So in production, we're going to be using this with combine different tools so that if they have questions about if they have PDF documents, for instance, that they want analyzed in a specific way, and we have a process, we're also going to implement a tool that will be able to read in those PDFs, extract all the information it needs, process that information, and then spit it out. So lots of different really exciting things there, and go over how we have different databases set up with different groups. We actually have 4 running vector databases right now, where we have the ag website set up with a group called CELT, Center for, and I forget what it stands for, Teaching and Learning Center at UK. We worked with them and we created a database for them. We worked with OptimalCT projects, which we're going to talk about in a second. We created a database for them so we can search up surgical information and find that pretty easily. And those databases can live in parallel with each other, so they get to just sit on the same machine. And then if we want to ask a question that affects each individual one, we can pass that into the same process, and the LLM is able to determine which database it should search for. So if we have an ag question, we can ask that, and it'll go to the ag websites. If we have a SELT question, we can ask the LLM, and it'll figure out it needs to ask the SELT database for information there. So that is all really cool applications of RAG stuff. Anybody have any questions about how we use it? Yeah.
What if the data that you feeding into the model show inconsistent information? For
Mm.
example, like if one document said, that in certain tests it's like a straight.
Yeah.
Another document said it's not.
Yeah.
How does the model?
So right now we want to be able to curate the data specifically for what we think is accurate. So anything that we put into these things, we want those to be like true, accurate information that we would want to represent us. So if we want to provide the LLM data that says this thing is true, then we would ideally want that to be true. If it's not true, then we just need to be able to take that out. So that's a pre-processing issue of being able to identify what data is right, what data is not right. Because ideally, we wouldn't want to be telling the information, telling the LLM information that's not correct, right? Does that make sense?
Yeah, so your model specifically finds that like really similar
Mm-hmm.
like wording.
Yeah. Yeah, so it goes through and it identifies which websites have contextually similar information. So if I ask a question, like going back to the previous example, if I ask a question about the circulatory system, it will look for things about like the heart, the veins, stuff like that. But if the information in those documents is not accurate, then that is going to be an issue for the LM because you're telling it something that's not true as something that should be true, if that makes sense. Yeah.
Sorry, last quick question.
Mhm.
How many, like, for example, like PDFs or any other kind of documents
Yeah.
do you need to create a model? Like,
So for training an adapter, that's one thing. You need a very large set of data. So that wouldn't be PDFs, that would be a specific structured format that you need, but you would need a very large number of examples. For something like with RAG, you don't need like any specific number. You can have one and it'll search that. You can have thousands and it'll search that. And the way that RAG works, it is able to search thousands pretty quickly. So like we can, I think the SELT website is the smallest that we have up here. There are maybe a couple hundred entries in that, but then the CTSNet database that we have has like 20, 30,000 entries in it. And they can search in almost like, I would say like 3 seconds. It can pull out documents that it needs. So these things are really fast. And the size of how much data you input it doesn't matter for RAG. But going back to adapters, if you want to train an adapter, that is a more intensive process and it can affect the model better, but it requires a lot more processing of creating that data set. Does that answer your question? Yeah. Yes.
Actually, okay. So let's start or?
Do you have a question?
I had a question.
Yeah.
Okay.
Is there a question online?
online? In production, what vector databases or vendor are we using? Can they be hosted for the UK community through an API?
Yeah, so we don't host them through the API. We could make that accessible, but right now you would just have to go through us. We would take that in and then we would create the database for you, but that would not take very long at all. So that is something that we could expose in the future, and it probably wouldn't be too hard. In terms of which vector database we use, currently we're using FAISS, which is Facebook AI Similarity Search, I think. But how that works is we could use anything, but we just chose FAISS because that was the easiest. What was your question?
So I was wondering, with the ag websites, for example, I'm kind of curious how much data you could actually search for. So
Yeah.
if you have all the extension articles, or all websites, then you could potentially add all the extension articles, which is a lot
Yeah.
larger set of verified things. You can also then start adding all of the research papers that all of
Yeah.
have written. And if you did that search with the pests, in one case you're going to see, if you did a circle around it, you would catch a lot of different pests, different weather information, peppers. If you had all those research articles, if you try to grab the same top 10 related papers, you're going it might hit just a very small, very specific area, kind of general context.
Yeah.
Is that an issue where how do you
Yeah, so how we solved for that was for instance, with PDFs, a lot of the PDFs are have like a lot more information than a website. So if we were to try to store that, that would be much harder than if we did just a website. So we actually index each individual page of the PDF, so its contents will be able to be extracted. And then when we're searching, we're able to identify which pages are most related to the query, put that in the context, and then the LLM can answer the question, because the LLM, it provides the processing power here to like process the language question, identify which of the information it's given that it needs to kind of spit out to respond to that question properly. So it doesn't just spit out the information that it finds, it also reads the information it finds and then puts it into a format that properly answers the question. So it wouldn't be too general or too broad, hopefully, because it is able to read the information that you give it and then give you an answer that is right at where you want for the question that you asked. And then if you are unsatisfied with it and you want it to be more broad, more specific, you can ask it, because it keeps the context of, this is what I said, this is what I was able to look at before, and then it re-asks the question, searches again if it needs to, and then pulls it back out.
So a very search window.
Yeah.
Okay.
Yeah. So you can control like how much it finds and how much it doesn't. Yeah. Any other questions?
I want to talk about the data hallucinations, because I often face the data hallucination problem when using the other LLM models. But how accurate this LLM factory is, because what are the chances of getting a data hallucination problem here?
Yeah. So in terms of, you're saying just the accuracy of the responses. So for
using the data, will the while working on the project and uploading my data into the RSE, am I right?
Yeah.
So there must be some minor chances of getting the data hallucinations. So do you have any numerical data or statistical?
yeah. So the short answer is not exactly, because LLMs are just extremely hard to grade in a numerical way because of how they are just generally, where the language is, it's hard to just judge the language whether it's right or not with a model. So you would have to go through and handpick, is this right, is this not, and that takes a lot of effort, obviously. So what we generally try to do is we try to set these systems up, let them run, and then just play with it, see if we can find any issues, anything where it's going wrong, if it's giving incorrect answers. And we do that enough to the point where we can get a good sense for, is this accurate on this, is it not? And also on this specific case, it will respond with the links to the documents that it pulls out, so that you can actually go check it yourself if you need to. Like if it gives you an answer and you're like, I don't really trust that, it'll give you the links so you can click on it, go read the article where it says this is the information, and it should hopefully give you some peace of mind of whether this is right or not. Does that make sense? Okay, cool. Yeah.
Sorry, one more question. So I know other over LLM programs like Copilot doesn't really allow us to pull specific source that the model uses. We search certain topics, right?
Yeah.
Do you think you can add that kind of feature as well?
Yeah. So to do that, we would use some of the tooling stuff that we talked about earlier. And the goal for us on this is to add stuff like that in. So like you'd be able to give it a website and it would go scrape that specific website that you want to look at and use that. And you would be able to upload a file and it would be able to go and read the file and use that as context. So does that answer your question?
Can we ask the model to say like, give me the data and results, and it spits out the results? Can we ask like, provide a reference source where
Yeah.
the model pulls the information? What page
Yeah.
of the PDF?
Yeah, so that's what I was saying to him. So any of the responses that it spits out, it includes, if it did search one of these databases, it includes links to the URLs of where it pulled from. Yeah, yeah, yes.
Okay, I just want to talk about the accuracy of how you get information. So you put up the agriculture, you say you use search. Does it pull information from different engine, like searching from different places and then collect just one thing that you need, or does it give you different
So what it does is we create an initial database that exists. So we go through each of the websites that they want, we add those into the database, and then it will search that database for the most relevant documents, and then it'll spit like a certain number out. It's like 4 to 6 that it says these are what I found to be the most relevant pieces of information for this question. Here's the answer based on the contents within those, and here's what they were. Does that answer your question? Okay, cool. All right, I think we do have to move on, I think, but I'll meet with you afterward and we can talk then. So I'm gonna hand it over to Sam to talk about OptimalCT.
Good afternoon, everyone. There's not any information on my slide anymore, so that's cool. Hit what? X?
Next.
Oh, next. Where's next? Dude, come on. See, I might be a computer scientist, but I'm technologically illiterate. So, my name is Sam Armstrong. I'm a software engineer in the Center for Applied AI. We're running a little bit late on time, so I'm kind of going to speed through this project a little bit. So this is OptimalCT. It's a collaboration with us and the Division for Cardiothoracic Surgery. The problem that it's trying to address is that there's a Society for Thoracic Surgery database which tracks if a person takes a beta blocker before a heart surgery, and then also the outcomes based on if they took a beta blocker or not. In UK over the past few years have been consistently low in making sure this administration happens. And I think the national average is 94% get a beta blocker before surgery. UK is at 78.3%-ish, which is a statistical outlier, which isn't great. So the problem kind of under that, because this happens, the number's so low because people come from outside of UK's network and outside of the state to our facility to get heart surgery, and we don't have a really updated record that they're taking these medications. We don't have a great way to communicate with them. If they have questions, they have to come, ask a clinical care staff, which, takes up time. So what we've done is made an automated system to manage these communications, manage participants, make sure they're taking these medications weeks before, days before, and leading up to the surgery. So there's kind of 3 stages that the system goes through. The first stage is 2 to 3 weeks out from being registered for surgery, and it kind of verifies the information that we have in their EMR, which is electronic medical record. So the system asks them questions like, hey, it looks like you're taking a beta blocker, is that right? If so, what is it? And then the patient also has the ability to ask questions of the system like, what can I expect after my heart surgery? And then moving on to stage 2, which is a couple days before surgery, the questions kind of get more specific, and it provides some additional instructions on what needs to happen prior to surgery. So it confirms with the patient that they're taking a beta blocker and that they understand that they need to be fasting, I think 12 hours before the surgery, and I think they can drink clear liquids or something else like that. And then stage 3 is the day of the surgery, so that's when the system provides logistical information about, where to park. It gives them a map of the hospital, where to find the office and stuff like that. And then again, the big part of stage 3 is making sure they took a beta blocker before they arrive. So that's kind of the sequential events that need to happen in this system. So let's talk about how we deal with these kind of like open-ended questions. So obviously we use LLM Factory, and we use tool calling, which we've touched on earlier. I think we'll talk about it more in the second half in detail. But in this case, we use tool calling to query, external sources, the EMR, maybe some medical literature, to make these questions personalized for them. So for example, it looks like you're taking the beta blocker atenolol. Is that right? Stuff like that. So, and then dealing with the responses to to say, you know, okay, this response to this question is an adequate response. That's kind of where the tool calling comes in too, where it adds additional context to a question. So if the system asks, hey, you're on this beta block, or when was the last time you took this beta blocker? The patient responds with, I don't know what a beta blocker is. It takes that conversational piece, goes out to their EMR, pulls atenolol that they should be taking, comes back and says, okay, it looks like you're taking the heart medication atenolol. Is that correct? And the patient's like, oh, atenolol, yeah, of course, took it this morning. Great. So it takes that response, pulls out the pieces that are necessary, and then structures it into a report that can be viewed in real time from a website by the clinical care team. And then at the end of, when the patient arrives for surgery and they're all checked in and everything, the system provides a big report of all the questions and answers that a participant gave, and it goes over, or the clinical care team can go over it with the patient before surgery to make sure everything's okay. So that's all I have time for. If you have any questions, find me after. So the next part of this is I introduce Dr. Doug Boyd, our favorite collaborator, and the director of the Louis B. Nunn Center for Oral History, and he's going to talk about transcription and whatever it is, of, I can't say it, of transcripts.
Lunch is coming soon. Unfortunately for you, the guy with the PhD in folklore is standing in your way. But I direct the Oral History Center here at UK, the Louis B. Nunn Center for Oral History at the University of Kentucky. We have a collection of over 19,000, bordering on, honing in on 20,000 interviews in this collection. These are long-form interviews, sometimes, 2 hours, sometimes 6 hours. So there's a massive amount of data that we're covering here. The interviews range and are part of about 700 different oral history projects. These get used by people all over the world, researchers all over the world. When I got here in 2008, we'd brag that 200 interviews would get used, and now it's about 200,000 are using them all over the world. Kristen, you held up a sign, and I can't read that sign, so. Okay, oh my God, you're fantastic. So the dirty little secret of oral history archives is that in 2008, when I got here, nobody actually used the interviews once they made it to the archive. It just was, there's a few people in this room like me who grew up listening to music on audio cassette. And the rest of you have no idea how much work it went into finding our favorite song when it was on the second side of the tape in the middle. The amount of guesswork and back and forth that you had to do. Well, it's no different. Using something that's time-based, on time-based media in an archive is going to take time, and it's going to take a lot of effort. We need text in order to effectively navigate and make discoveries in these collections. And so 2008, I created a software system called OHMS, the Oral History Metadata Synchronizer, to really enhance access to online oral history, and we made it open source and free. It's now being used by over 700 institutions in over 50 different countries, which is really, really cool. It transformed our operation at the time. But now, once again, I think we're facing a fundamental shift again, because the Nunn Center is now, through all their various collaborations and such, bringing in 1,000 new interviews a year. So we're growing pretty rapidly. The OHMS system was manual. So it was a system that required humans to take a moment and listen and tag and transcribe, because transcription was done by humans back then in 2019. And in 2019, I did a Fulbright grant to Australia to really dig into this issue and explore and brainstorm ways to maybe harness NLP and AI in order to solve some of these problems, and kind of came up with this vision for a suite of tools. The individual tools were something I called the verbatomizer. The verbatomizer was going to create a verbatim transcript of each recording. The describalizer. The describalizer would create a comprehensive description of what is being said in the interview. It would extract keywords, obviously, but it's going to create a comprehensive summary. It's going to maybe extract all the questions asked over the course of an interview. It's maybe going to do GPS coordinates for all the place names, and maybe it could even do something like sentiment analysis and kind of do a measure of emotion as it is expressed throughout these interviews. And I sat on this dreamy vision for about 4 years. Pretty powerless to pull it all together, but when connecting with the people here, the Center for Applied AI, we really now find ourselves on the cusp of basically launching this system that is going to absolutely 100% transform our workflow. The Speak Easy system, which is what we're calling it, and mind you, I think we won in terms of names, in terms of the competition, AgriGuide, come on. Push further. Speak Easy, which was brilliant. Thank you, Kristen. It's going to basically put this all together, and again, I don't use this word lightly, transform our workflows and allow us to fully process every single interview that comes into our collection. And I often say to researchers who use oral history in the archive, it's the moments that matter. It really is. Think about it. In an oral history interview, yes, you've got the topic that's being discussed, but there are thousands of potential data points throughout that interview. Seemingly miscellaneous data points that are embedded in the ramblings and deviations and digressions that everybody does. And some of those digressions and ramblings are where some of the most powerful and important information is preserved. And so the problem is, how do we get to that? And through Speakeasy, we're going to be able to really construct a process that will guarantee that we're going to be able to provide that granular description, that granular mechanism for discovery. And I think phase 1 is going to be implementing this back-end processing system. Phase 2 is going to be like the magic that ensues when we have the ability to find all of the needles in all of those haystacks. When the researchers are going to be able to, again, create searches and queries that are based on things like emotion and based on things that just were not possible, I think, in an archival interface before. So all the recorded interviews are really, when you create oral history, when you do oral history, you're really doing it so that you put the individual stories on the historical record. And the problem is that just conducting that interview only creates the potential that interview is going to be on that historical record. And really, truly, OMS was great. It was a manual system. So of our 20,000 interviews, we really only have granular access to about 6,000 of those interviews. And then that granular access is only really semi-granular in the grand scheme of things. And Speakeasy is really going to really completely lift our game, I think, to a point where the expectation is everything that comes in will be transcribed, everything that comes in will be comprehensively described, and everything that comes in will be comprehensively searchable, potentially, and discoverable. So, and I really am grateful for the team here to, they truly are really making my dreams come true, I think, from that perspective. So, and I look forward to hearing more from you all about what's going on, but I also, am happy to kind of talk about anything that you guys want to talk about with regard to answering questions about this system. It's going to be pretty amazing. Thank you.
And it's lunchtime now, so everything's set up in the back of the room. We're gonna have a long lunch, an extended lunch, so you can enjoy it, eat, and get the chance to talk to us. So go ahead, head back there. For those that did have dietary restrictions on their registration, the middle table in the back is the table that has those specific lunches. And thank you, everybody. Hello. I hope everyone enjoyed their lunch. We're going to we're going to get started with the kind of second half of the day, which is definitely a bit more technical, talking about some API stuff, things like that. So here's kind of what we're going to cover over the next hour or so. So we're going to talk about the basics of API requests and how to get that information out of LLM Factory, tools like chat completions, embedding, transcription. We're going to talk about LangChain, as well as do a bit of graph databases, and then at the very end, talk about how to train an adapter in LLM Factory. I just want to highlight that if you're in LLM Factory working with the tool on your own, we have a user guide that's built into it. So it is always a great place to go to see if you can get an answer to your question if you're working with the system. But with all that aside, I'm going to hand it over to Vaden, who's just going to give a quick intro into API stuff.
Hello, I'm Vaden Logan. I am a developer here at CAAI, and I'm going to talk about the basics of using our API. So I guess the first thing that's important to talk about, I'm guessing that not everyone here is super technical. One way to query the model is, of course, to go to our website, and you can talk to our models there, but there's an alternative, and that's using APIs. So on the screen behind me, you see this little Python script. The first line is from OpenAI, import OpenAI. LLM Factory's API is compatible with OpenAI's API, so you can use OpenAI's API library to communicate with our system. After that, you have to create an LLM object, and then in that object, you specify the API key, which I will show you on the next slide how to get one of those, and then the base URL. So when you go to the LLM Factory page, if you go up to the top, there is a section for API keys, and you can generate an API key. And then for the base URL, it's just dataai.uky.edu/LLM-factory/OpenAI v1. And then API key slot, that's where you put your API key that you generated. So once you have created your LLM object, you can call this chat completions function, and then the model will give you a response. The first field in this function is the model field. If you leave that blank, the query will hit our base model, which is just Llama 3.0 right now, but you can also specify an adapter or an adapter configuration. You also pass through your message, of course, and then your max tokens. Tokens correspond to how long the response will be. Like 100 tokens is a shorter response, 1,000 tokens is a longer response. After you call that function, you access the response from the model by doing response.choices. 0 just means the first choice that it sends back, then message and content, and that's how you get the response of the model. So this is a list of public adapters that we have that you can use. If you want to use any of these adapters, you just copy this ID that's right here, and you plug it in right here. Oh, I forgot that it did this. Yeah, you go to the adapters page, and you get here, and then you can copy the adapter ID like I said. If you want to use adapter configurations, and basically these are just adapter configurations let you mix and match different adapters so you can set different weights and kind of combine adapters, but it's the same thing. You just copy the ID and you pass it in this model field right here. And then, like I said earlier, there are a number of adapters that are available for all LLM Factory users. Some we've already mentioned, like the obliterated model, the uncensored model, and then some of these are just good for code generation, and then some graph database querying adapters. Okay, I'm going to hand it off to Mitchell Klesty.
All right, so that's just generally how you use the API, sorry. But how do you apply the API for your projects? So having the capability of it being OpenAI API compatible means that any tools that work with OpenAI stuff we can also use. So like LangChain is a big one where their system is OpenAI compatible, so it is also compatible with our API. Just making that clear. So to use the chat completions API, you want to be able to get a response from the model, so you do what Vane talked about and just go through all that and set up, like you said, the model, UVID, and you pass in messages. So the messages in particular is, I think, what I'm talking about next. So yes, going deeper into that. How that works is when you want to query a model, you want to give it basically a system prompt, which is either like something really simple. You don't even have to fill out this field. It'll be like telling the model how it should act. Generally, it's like you are a helpful assistant is like a really basic system prompt. But you can change that, and if I wanted to tell the model to like act like it's a pirate or something, then it would start talking like it was a pirate if I put that in there. And then with the really basic one, like up at the top, you just put in user message. You set the role to user, and then you set content message. So whatever you want to say to the model, it's the same thing as if you were like typing into ChatGPT or into our interface with like, here's my query, and then hit enter, and then it would spit out the response. If you want to, through the code, to be able to kind of have a conversation with the model and have it store it, like if you were to, in ChatGPT or through our interface, if you were to like put messages in and then continue a conversation, how you do that is you add the system prompt at the beginning, and then you have user message, model message, user message, model message, and you just go back and forth between role user, role model, and then the content for that message. So the first one at the top there would be the first one that happened in that conversation, and then the last one would be the new one that you're telling the model to respond to. So then Embeddings API. So we open up Embeddings API for stuff like RAG. Like the RAG, how that works is by using the Embeddings API to vectorize the data, and then we can create the vector databases and vectorize the queries so that we can make those queries. So the Embeddings API is how we do that vectorization, and the format of this is super similar to everything else. You first create your LLM object by connecting with your API key and your base URL, like Vane went over, and then you set up an embeddings object and you run that the LLM object embeddings create, and you set the model to blank for us. Generally, the reason that we do this is because the model, if you're using like an OpenAI model, you want to be able to choose individual models. And in the future, when we support multiple embeddings model, multiple chat completions models, you'll be able to put that in to fill it in. But for now, since it's the same model for every single API call that we hit for chat completions has its own specific model. There's not multiple base models yet. Embeddings has its own base model. Eventually, there will be, or there may be, depending on which type of model we use, different models that you can put in there. But since it's the same model for everyone, you just use an empty string. So that's why that was set up that way, just to make it easiest to use. You don't have to go look for what field I put in there. You just leave it blank. But that field is required through OpenAI API, so it just needs to be in there blank. And then you put your input. This will be a string, whatever you want to vectorize, and it'll respond with a set of vectors, or a vector which is just a set of numbers that you can use for later applications. And we'll go over later LangChain. LangChain is very useful for wrapping around this. So using this yourself is going to be kind of difficult, but if you use a wrapper like LangChain, then it helps a lot with transforming this vector that gets generated into something that is actually usable to you. So next, transcriptions API, like we talked about, very similar again, but instead of the empty string for this, we want to pass in whisper1, and then instead of a message like you would do with the embeddings or the chat completion, you don't want to have it transcribe a string, you want to transcribe an audio file. So you put the file with the path to your file on your computer, and then that will be loaded up and that'll be passed to the model. The model will receive that file, transcribe it, and respond with the string of how that was transcribed. So anybody have any questions about that before we go into LangChain stuff? All right, so let's get into how RAG and LangChain work from a more deeper level. So LangChain, what that is it's just a framework for developing LLM applications. It's really useful for RAG, but you can use it for pretty much anything involving the LLM stuff. So it provides templates for just basic chat completions. We have our OpenAI stuff that is like just the standard OpenAI, but they have a wrapper that kind of like makes it, or they try to make it more simple to where you can add in specific pieces and control more how that flow works rather than just being at the weeds of here's how the OpenAI works and I'm going to do everything. They try to wrap around that. They have same thing for Embeddings Retrieval. Instead of using the actual OpenAI code, they put a wrapper on it to try to make it more simple. Vector database creation, similarity searching, same thing there. They put wrappers on that, so instead of just using the embeddings model directly and creating the vector database from the outputs of that yourself, you can use these libraries to go through and create the database much simpler with one function call instead of having to like deal with all those vectors yourself. And then web loading is another piece, so that's how we do this stuff like with AgriGuide that we talked about earlier, where we pull down content that is hosted on a website and we perform RAG searching on that. So we're able to identify, like give LangChain a URL, and it'll pull down the text context of that URL, and then we can perform RAG on that very easily through LangChain. And then tool calling, we'll get into that again, but tool calling is very simple with LangChain. If you wanted to use tool calling outside of LangChain, there's obviously a way to do it, but it's much more difficult, so we're just going to go over how you can do it in LangChain. So chat completions template, this is kind of what I was talking about. You can set up a template for, like, if you wanted to pass this into the model, this would be easy enough to do in normal Python, but this kind of helps you make it more structured, more simple for your applications. So say that I want to translate this sentence to, and then pass in a language, pass in a query. I want to translate hello world into Spanish. So instead of having to like regenerate that structure for the chat completions every single time I wanted to do that, I would just have to pass in to that template Spanish hello world, and it would translate it from English to Spanish. Embeddings, so kind of similar to what we went over earlier, just a reminder of how all this works. It'll create a vector, which is just a long list of numbers, and so like it'll convert hello world into this really long string. And in this, it has 768 elements with our model that we use. So each string gets converted into one of those, or it gets converted into a list of 768 numbers. And you can think about that like coordinate plane, like we did earlier, but really it's in 768 dimensions instead of 2 dimensions. So it's a lot more complicated than just coordinate plane, but it helps me a lot to kind of think about it as 2 dimensions instead of 768. But essentially within that vector, we store the meaning of the words. So hello world, what does that mean contextually? That gets stored in 768 numbers. And then we're able to, like we went over earlier, find similarities between, if I were to find a point that was very similar to hello world, and across those 768 dimensions, when I do like a Euclidean calculation of how close is it to that point, that would allow me to find out how related it is to that element contextually. So again, similarity searching. You encode your query and then find which ones are similar. So you can do this in multiple ways. You can do this within a specific radius of how close it should be to it, or you can do it by finding the like n closest elements, and that's another way, because like if say that you don't hit anything within that specific radius, that might be an issue, but you might be able to find something that's pretty similar, but in terms of your database, it's similar enough. So you find like the closest one that might be outside of a specific search radius. So that is also pretty helpful. So this is a longer example of how we use LangChain. So we actually wrote a Python library to like kind of mix in LangChain and our specific embeddings model, because they use, the way that they set up their embedding stuff is using one tokenizer, and then the way that we do it uses another vectorization tokenizer thing. And each different model that you use is going to use different ones. So we set up one that converts with our specific vectorization model and the tokenizer for Llama. So it enables you to talk to our models specifically through LangChain. So you want to import your libraries properly and then set up the CAI EMB client. So this will look the same if you set up directly through LangChain and try to connect to like OpenAI or something. But again, this is specifically for our model of embeddings and our model of Llama. And then you set up your API key, model, API base, so that'll all be passed in, just like it was with all of the other API calls and everything. And then you can create a set of documents, so that'll just be strings, or that can be a LangChain document object, which will be like, you can import specific files and convert those into sets of smaller documents that can be processed. And then if you want to create a vector store, again, we use FAIHR, so that's like, once again, Facebook AI similarity search. We use that one in particular because it has good compatibility with LangChain, but there are other options. So we use that command FAIHR from text of documents embeddings. So you want to pass in the documents that you want to encode, and then the embeddings, the model that you set up for connecting between the embeddings model and the language model client. So then you're able to call results vector store similarity search, and then you can pass in your query. So that'll be whatever string you want to search the database for. And then K is the number of closely related elements that you want to find. So this one in particular would find 10 of the most closely related elements. Web loading. So like we went over with AgriGuide, you're able to just like take a query, load up the website, search that website for the relevant context to that query, and then give that to the LLM. The LLM will then respond to it. So the way we do that, we import the web-based loader from LangChain. So that's a LangChain package that is predefined, and really simply in like 4 lines or whatever, you're able to pull down the contents of that website, and then recursive character text splitter. So what that does is it chunks up the documents into specific pieces. So then that allows you to narrow down the field of search. So if you have like a long document that's this long, you want to chunk it up so that each individual one can be passed into the LLM if it's relevant, and you're not passing in irrelevant context to the LLM. So then we pass this into the LLM, and it gives you the output of whatever is relevant to your query. Tool calling, kind of like how we talked about earlier with the weather tool calling example. If you want to have if you want to connect the LangChain stuff into code, how that works is you would define your tool in your code, obviously. Excuse me. And then you'd be able to, you generate a lot of them, whatever tools you need, and you can combine them all and provide those to the LLM. And then the LLM, from the description and the name of the tool that you give it, it will be able to choose which tools it needs to use. And it can use multiple tools, or it can use a chain of tools and select the individual ones that it needs to use. So how you do that, really, really simply, like one of the most basic tools is just importing the LangChain tools object, and you can put this @tool decorator on there and then define a function. So in this case, it's multiply A, B, and then that returns A times B. So we have multiply name. So we name the tool based on what the function is called, or you can specify it directly. And then you give it this doc string, or whatever this is called, which says multiply two numbers. So that's a description of the tool that the LLM is going to look at, and it's going to say, is this what the query wants me to do? So if I were to ask it to multiply 2 and 3, then it would look at the description of this tool and see multiply two numbers. Oh, that's what I want to do because I am being told to multiply 2 and 3. So that's two numbers, I need to multiply them, go to this tool. So then it sees that A is an int and B is an int. And then it sees, how should I transform my input into A and B? So it has 2 and 3, and it converts those from strings to integers. And then it goes through the code, return A times B, which would be 2 times 3. It would return 6. 6 would be given to the LLM, and then the LLM would look at that context and see, how do I properly respond to that question? So multiplying 2 by 3, 6. It's pretty straightforward, but basically the fields that you want to define are the name, which would be the name of the function. Multiply two numbers would be the description, so you can define that with that doc string. And then you want to define how the args should be taken in. So like you want to make sure that you set the typing and everything right on your args so that you're not like, it's not trying to multiply 2 as a string by 3 as a number, because that obviously would cause issues in your code. So if you want to define a custom tool, because this is probably the most important piece of this, you want to be able to define not just simple things like multiply by number. You want to be able to like give the tool specific properties and be able to like go through and set out, how do I make this work for my specific application? So one way that we've been looking at it is you can extend the base tool class and create your custom tool, which has your name and description that you can pass in when you define it. And also whatever custom fields you want can be defined as fields of that class, properties of that class. And then you define a run function and an asynchronous run function. So that means that the tool can be called synchronously or asynchronously. And that allows you to say whatever it is. So like we have the placeholder foo there, which is just like a random function that does something. And we take in, when we run, arg1, arg2, and then we pass in the custom field as well. So whenever you run this function, it is going to look for the description that you give it. So whatever field it is, it's going to try to process out from your input 2 integers, or 2 strings, I guess. Sorry. arg1 in this case would be string, arg2 would be an integer. So you define what those are, those would get processed, it would put those into that field, and then it would do whatever function you want on them and whatever function you want on the customly defined field. So we have some example code set up on this GitHub link, so I think share that with everyone after the presentation. But that goes through some of the LangChain demos that we set up that you can use to connect to our system and run everything through and figure out how LangChain works. Anybody have any questions? All right, then I'm gonna hand over to Aaron. He's gonna talk about graph databases.
Hello again. So yes, I'm going to go into a little bit more detail about the graph example that I mentioned earlier in the session here, and kind of talk, not necessarily going into like the code, but talking about the specific methods that are used, some of the challenges that we have with interfacing with databases like graph databases, and how we can address those. So to briefly recap, we have a FIHR database, commonly used format for all kinds of healthcare data containing different nodes about patients, observations, treatments, all that stuff, and they're all connected in different kinds of relationships. So we want to be able to use it as a RAG source, so that way we don't have to train any kind of adapter or anything on this sensitive data. And we can also limit access to the data at a user level. We can make sure the LLM isn't giving away data it's not supposed to somebody who shouldn't have access to that by controlling what access the LLM itself has. So we can use a graph database. We chose to use Neo4j in this example, but there are obviously other platforms that you can use to host different graph databases and different languages you can use to interface with them. And we're going to use LangChain again to try to do these queries and get the results, but there's a couple different ways that we can approach this. And so I'm going to talk about two different methods that we can use to try to interface with this database that both kind of have their own strengths and weaknesses and use cases. So the first approach is to actually use a vector store instead of the graph database directly. And the way we can do this is by taking all of the different attributes that a node has and kind of summarizing them into like a big paragraph. So LLMs are built to naturally be able to work with sentence structures very well. So that's kind of an advantage of using this. So we can take kind of each like field as you see, and then we give it a value equal to whatever that value is in the attributes. And we end up with a big paragraph for every node. Then we can do some of the vector embeddings like we've talked about to embed those into long lists of numbers, and we put those in a database. And then there's all kinds of different algorithms that we can use to effectively search that database, figure out what the most relevant vector would be to any kind of incoming query, and then use that as context for the LLM. We can control how many nodes get returned when we want to search it, or we can also just query the connected nodes to whatever is gathered from the vector database, and that way we can kind of build a small subgraph basically that we hope will contain the information that we need based on what we're asking about. So one of the problems with this here is that if we go back, this is just one example of a patient node, and we have all kinds of other nodes that are connected to it. And so the problem is if each of those nodes has their own paragraph that we need to embed, and then we combine those all in as context for the LLM, that's going to be a lot of redundant information, and a lot of the time it's going to be too much for it to even be able to use. A lot of these LLMs have context limits, the number of tokens that they can take in as input. And if we include all of the nodes that are connected to something we're interested in, it's very likely that we're going to run past that. So we need to find a way to limit the data that we're gathering to only what's actually relevant to our query. And that then raises the question of how do you determine what is relevant? And what we found is that kind of the best way to do that is actually just to make another LLM call. So we can pass in an original question and give it instructions and say, these are all the different node types that we have in our database. This is what each one means and kind of when they would be relevant, and then have the LLM choose which node types are actually important to our query. And then we can only get those node types, so that way we limit the context size and avoid gathering a bunch of redundant information. So as an example, if we ask it, how much did this colon scan cost on this certain date? What it will do first is search the vector database for the most relevant node, and what that is going to end up being is like a procedure node here that contains data about a colonoscopy that's done on this date. And so something nice to note here is that the wording doesn't have to match up exactly for the vectors to be matched. So we ask it about a colon scan, and then it actually finds a procedure about a colonoscopy. And the vector embeddings are able to deduce that those are similar enough that when we do a similarity search, it still matches correctly. So that's an advantage of using vectors, is it's a lot more flexible to different phrasings or spellings or anything like that. So once we get the procedure node, we can then gather all the related nodes. You can see we have a claim node, and the claim node is going to actually contain data about the cost of this procedure. And so in the output, it will tell us what the cost was because it gathers data from each of those nodes about all of their attributes. So you might be thinking then that this approach is going to have some problems. What if we have a query that needs a lot of different distantly connected or unconnected nodes, right? So if we ask it like we used in the first half, how many patients are there under the age of 30? Well, to be able to answer that, we have to actually look at all the patients and figure out how many of them are under 30. Being able to gather just like a single node isn't going to help here. And so there's different ways we could approach that with changing how many results we get from the similarity search, but overall, that kind of question isn't answered very well with this approach. And so that's why we have a different way to do it in those cases where we can directly query the database. Like I mentioned earlier, we would have the LLM actually write the Cypher queries that are going to be executed on the database. It executes them basically as a form of tool calling there that's just done behind the scenes by LangChain. and then give us the response there. So we ask it here, what is a certain patient's marital status? And it creates this cipher code that matches a patient with that name and returns a marital status. So this is actually going to run into some of the same problems as the first one, which is the context size. In order for the LLM to be able to write this query, it has to know what the structure of the database actually looks like. It has to know what kind of attributes and nodes it's looking at. And the FIHR graph schema is very long and very complicated. And providing that all to the LLM is going to be too much for it to handle again. So we can do basically the same approach we did the first time, where we can limit the schema to only the most relevant node types, and we can determine that based on the output of another LLM call to decide what is actually relevant to our question. We found that it also helps a lot to pass in different example nodes. So the schema is only going to give it a list of what all the attributes are for each node, but it doesn't tell like what that attribute actually stores. And the schema can be very complicated here. There's like 6 different fields that all contain the name, and they're all slightly different and have slightly different names. And so knowing which one to get can be hard. So if we pass in some example nodes as context to the model, then it can use that to get a better idea of what it's looking at. And so it uses that to determine that actually the attribute it's looking at for the marital status is marital status coding 0 display, and it returns that instead. And like I had mentioned in the first part, this works with larger queries that are going to involve a lot of different node types that may not be directly connected with each other. So we can ask it about patients under a certain age, or ask it about how many conditions a certain patient has, or all of that. And we can kind of connect those together. This isn't a perfect method either, though. It can still struggle with some of the attribute relationship types because there are so many and they are kind of so complicated to learn. This is also going to be less robust to different spellings. So if we went back and we asked it about the colon scan on a certain date, it would try to find a procedure node and it would match up the colon scan word exactly, which wouldn't match with the actual procedure. And so a combination of both of these approaches is what's going to work best, where these vector stores work very well when we're asking questions about a smaller subgraph. If we only want to know info about a single patient or a single treatment or encounter, then we can do that and gather all the kind of generally related information with that. But if we want to ask more general questions that would require access to the entire database, then we can use direct querying instead. And so like Mitchell mentioned before too, we have examples of this type of thing as well at the same GitHub link. So feel free to go there and check that out, try to download it and work it out yourself. Are there any questions? Yes.
Okay, so on the part of the sensitivity, how do you distinguish which user is supposed to get what sensitive information and which one is not?
Right, so that would just come down to programmatically at a user level being able to restrict what the LLM can access, and we can do that through the tool calling, where if we were relying on the LLM's own knowledge, there's no question, there's no telling what it might like answer back. But by doing this, it's only going to respond what the context gives it. And so if the context doesn't provide an answer to it, it's not going to try to guess or anything. It'll just say, I don't have access to that. And so we can do it that way, where if we keep the LLM from getting the context in the first place, it just won't answer.
So I wanted, assume this is working, not, sorry. I wanted to give a response to that. When, especially if we're talking about tool calling, and see Justin over there, he's painfully aware of this as well. FIHR endpoints, which is now mandated since 2021, at least in healthcare, it's a specification for how you get data in and out of the system. There's 2 ways to interact with that endpoint. One of them is as a system, meaning like one big system that has access to all the data in the other system. The other is to act as a user or an application. And with FIHR, you can get very granular to say, this is Cody, you can only have access to things in pathology that they should have access to. It's going to be audited. So in that way, the LLM is an agent, your agent doing your bidding, and it's going to be audited and treated the same way as if I went in and started printing out information from anybody. On the system side, then you have to have secondary controls in your application that says, well, you're asking these questions, but am I making sure that we have the same
Anything else? All right. Well, then to briefly tie it all back, all of these tools that me and Mitchell have just talked about that you can use programmatically, all of this can be using the models that you actually train on the site itself. So you can train an adapter or whatever there and then access it from these programs. So to go more into how to actually train those adapters in the first place on the site, Caroline will be next.
Yes, thank you, Aaron. So talking specifically again about LLM Factory and training an adapter on that system, but the key to training an adapter is having the right data to train the adapter. And so you have to have it in a specific format and you have to have a lot of it. Some of the other tools that we've talked about with RAG and tool calling allow you, if you don't have a extremely large data set to train an adapter, do similar things. But if you have a bunch of data and you can get it into the required JSON format, you can upload it into LLM Factory and train your model. So this has a screenshot of like the kind of highest level of how the data to train an adapter needs to be formatted. This is an example with a little bit more detail, but this is generating the data, getting it to output in that specific format. This is again, making sure that it's in the correct format. If you don't have it in that format, it won't change the adapter in the way that you're hoping. So I'm now gonna kind of talk about LLM Factory specifically. There's gonna be a lot of screenshots in here, and I do wanna emphasize that this is also in the user guide document that's built in, so you can refer to that in real time as you're training an adapter as well. But to kind of give an overview and talk about it, you can upload a data set in the system. You can train a new adapter. Either button gets you to the same place. And once you have uploaded your data set, you can create a job for it. So we use Clear ML that kind of manages our jobs, and training, again, all takes place, I believe, on the DGX. And so this is a big screen with a lot of information, and this kind of lets you get even more customization into your adapter. So configuring it, the kind of default settings that automatically come up when you start to train an adapter, they're optimized. We set them like this for managing resources, but you are welcome to change these. You'll want to name your adapter. You'll want to, right now, the only base model available is Llama 3 8B, but soon there will be other base models you can select. You'll have to decide how many cycles through the training data you want it to go through. Increasing that kind of runs the risk of overfitting a little bit, but it does continue to make it more specific. So this is all things you can kind of play with and explore to see what's best for you. The learning rate and things like that, all adjustable. One of the most important things on this page is the LoRa rank. And so LoRa is that low rank adaptation, the way that we're doing all of this. And so having it at a smaller rank, again, reduces kind of the computational resources, but if you increase it, it will continue to have a bigger effect on the base model. So it'll even further change the way the model speaks. So once you have your data set uploaded, you'll be able to track it from the jobs page in LLM Factory, and you'll also be able to activate or deactivate an adapter as needed. Right now, you can have unlimited adapters activated, but as more people start to use the system, we plan to maybe implement a limit of you can only have a certain number active at a time, but keeping, that's how you activate the adapter. You can review the adapter from the adapters page. You can activate it. I just went through that. But now you have an adapter. You have the data set that you trained it on. You created a training job. Your adapter has been trained. Then you have to evaluate it. You have to see if it meets your needs, if it's doing what you want it to do. And that is something only you can answer, so it's highly individualized, and it just takes some time of interacting with the model to see how it's affecting it. This looks different for every single person, so take your time in that process. This is kind of the interface where you can interact with the model. There's different drawers that you can pull out here where you can create new chats, things like that. This is maybe the most important tab over here is the configuring drawer. And so this is where you can give a system prompt, adjust your parameters like tokens and temperature, and turn up the weight of your adapter. So adjusting the weight of your adapter basically controls how much it matters to the model. So turning the weight all the way up increases it the most, and so that'll kind of enable the most specialized or domain-specific performance. You can save weights and come back and explore them again later. Something that's really helpful in the evaluation process is turning on the comparison mode. So being able to turn that on, you can side by side see how your adapter is performing with how the base model is performing. Now, this adapter isn't anything special, but if you have an adapter that is, such as maybe the uncensored model or whatever for your specific domain, you can see quite a drastic difference using this comparison feature. There it is, turning it up. Once you kind of have figured out a combination of adapters or the specific adapter that you want to use, you'll want to get its UUID or its unique ID, whether that's the adapter configuration or just the adapter's general UUID, and that all the way circles back to what Mitchell and Aaron both talked about earlier, plugging it in to kind of the back end of your code. This is a screenshot of what the adapter configurations look like. When I say adapter configurations, that means there are multiple adapters taking place within this UUID. There's also adapters that you can get just from the main adapters page. If you're just trying to do one at a time, you have the flexibility to do it however makes the most sense for your project. I know I went through that a little bit quickly, and it is in the user guide as well, but any questions?
I guess when you do something like that, you guys kind of guide us, because personally I don't know much of this topic and settings and change. I don't know how can I affect it.
Yeah, absolutely. We're able to help out with that stuff, and in my experience, kind of fine-tuning those parameters is the easiest part. The hardest part is getting the data to train an adapter in the right format, but that's also something we can help with.
So I'll just mention that what we found is when we fine-tune full models, and maybe what we're doing is pull out condition codes or pathology reports or determine from other case notes if there was overdose condition codes, that you can take this huge model that's been trained on trillions of tokens of text, and with 1,000 cases, you can force the model to only spit out condition codes. So that's great if you want to say, here's a report, give me the condition codes that you've been trained to spit out. You can even programmatically interface like what they were showing. Your application goes, sends a report, and you're expecting you get some subset of condition codes back. The problem with that is that then if you ask it, what's the best name for a cat, it's going to spit out condition code for colon cancer. So the benefit of this is that you get to leverage these massively billion parameter models, and then you can start turning the knobs. One of the papers we just released in last December, we did this. We took, and for those that care about medical or any kind of education, what we did is we took a bunch of data sets that were medically related. I think Vade and Mitchell and others were part of this. And we took and trained those particular adapters. One was free text, so we don't do it because it doesn't really work that well, but you can actually continue to pre-train. I can take medical text with no structure, I can train an adapter. We did that. We trained question and answer adapters, we trained conversational adapter, and then we trained another one that I think was multiple choice. Then we used the USMLE, and then the Indian, whatever, I forget the Indian name one, for multiple choice questions, and then we programmatically assessed how well did it do. So there's something called Optuna, it's an optimizer, and it basically lets us run through model evaluations or run through trainings. So we let that run over and over and over during Christmas when nobody was using the system to determine the optimal configuration of those 4 adapters to those tests. And on average, we had a 19% improvement over base models using both the adapters, but then using them in the appropriate conversation. Now, we were not leveraging RAG with that. If we have specific domains where there's maybe conflicting information or it's very different to try to smash those together, we can take and break up the data sets using RAG approaches to say, you're naturally from a syntactical embedding perspective, this looks like the same type of data. This looks like the same type of data. And you don't have to have 3, you could have 500 of them. And if you have the training data to begin with, which you can, what we need to show and hopefully you can do, is based on the question, select the right adapters with that embedded knowledge. Now, if it's like case reports or something, you may want to bring that in RAG. If it's thinking like a gastro person, or if it's thinking like a pathologist, those are the pieces that you would want to impart. And I think we can even do that in education programs, because we can take curriculum and say, what happens if somebody doesn't take calculus the second year? Will they be able to answer when it comes down to doing more theory work? Are they going to be able to do it? So I think there's applicable from a customization of a per question answering, but also in simulating what it would look like in training programs to say, what are the things that are needed, what are the things that are not for particular domains.
I'm trying to understand these adapter weights that you were explaining. So take an example of like the uncensored adapter, for instance. If you put an adapter weight at 50% there, would that mean that half of the responses that would have been censored would be censored still, and half of them wouldn't? Or am I understanding that incorrectly?
So when you go to train LoRa, it looks at some of your data set and it looks at the rank. Rank is essentially how deep it's going to get and how many parameters it can potentially change. Alpha is how loud the voice is that you're willing to yell at adapter. Alpha can actually be changed execution time too to say this is more important. The weights, if you have 1 billion weights, and some of those weights have been trained to say, don't approach these certain topics. You can go and look at the activation of when certain topics are coming in, what weights are activated. The way that they essentially deaden these things is they reduce those weights so that when there's a topic that comes up and it doesn't want that to be influenced, that it reduces that weight. So if you had something that was 50% of a 10% change in the model, and we know that says because of that particular rank, most of the questions that I asked now it'll answer and wouldn't answer it before, you could essentially slide that scale to say at what point does a rank 8 at 50% let some topics go through versus a 10% of a rank 64 to let those go through. It really is the balancing of those existing weights with that existing structure. It's not extending it in the way that we would think of extending, well, here's another path for the things to take. It's influencing the path of the initial collection of gradients for the whole thing. So, experimentation more than anything.
Any other questions? We're also going to be standing around afterwards if you want to talk one-on-one with any of us too. All right. Well, thank you everybody for joining us today. I really appreciate it, and I hope you learned something. And I'm going to share the slide deck with everyone later this week so you can review it closer as well if you want to. Thank you.